welcome back to my YouTube channel. Previously, my SPM physics for Form 5 will talk about a semiconductor diode, where in semiconductor diode, I'm going to use two types of semiconductor, a P-type and a PN type. I bring them together and they form a diode. Now, as of for today, then we'll talk about the application and how to get a direct current. So today, this video, we'll talk about transistor. Okay? So in transistor, it's actually a combination of three types of semiconductor. Okay? You bring in three types, 2, 3. Okay? Could be P-type, N-type in between, and P-type. Okay? So you're going to bring them together and make into a device, or the N-type, P-type, and N-type. Okay? There are two variants of transistor, either PNP or NPN. Okay? So if you would bring them together, it forms into a device. In your reference or perhaps in your workbook, the symbol for transistor should look like this. Okay? And then we have an arrow, and then we have a circle. Either it would be the arrow points out, or it's possible you find question, it's possible the arrow points in. Okay? The direction of the arrow represents the types. Okay? For going in, meaning you plug into it, right? Is P and P, plug and play, right? P and P. P and P is when the arrow points in, into the base. Okay? Point in means P and P. Then if you recognize arrow points in is P and P, therefore the one that points out would be NPN. Transistor. This is called the NPN type. This is NPN type, where it points outwards. So there are a few things that you need to know, so that helps you to better understand the what do the questions need in SPM. First, either PNP or NPN. Let's stick to NPN, NPN, I mean a dash NPN. The first one. First thing, you should recognize the symbol by the base. The one with a line is called a base. The one without a line is called the collector. The one with an arrow, either side, the one with arrow, it's called emitter. Some book, they will just give you a capital E, C, and B, capital, or B, C, and E. In some book, they never spell the whole word, they just let you know the initial, B, C, and E. So one way to recognize it is, the one with a base, the one with a line is a base, the one with an arrow, either outwards or inwards, it's emitter, the one without anything, it's called the collector. So it actually allows electron to pass through it under certain circumstances. So the base would control how the current would diffuse through it. It acts as a switch. Transistor work as a switch, on and off. Okay, controlled by the base. It's also called, transistor sometimes is also called bipolar. Some objective question. bipolar junction BJ, power junction transistor. In short, it's called BJT. Okay. Now, for simplicity, I'm going to use NPN to tell you how the switching work. Okay, NPN and PNP, they work opposite. Okay, when PNP on, PNP on, NPN is off. Okay, I'm going to make use of NPN for our question. I'm going to use, okay, this color, no, black. Okay, we start with a transistor. Okay, then arrow points out so that it's NPN going out, transistor. Alright, okay, there are a few things that you need to know. Okay, in order for it to work, okay, now in order for it to work, your collector, this is a collector, you need to connect it using reverse bias configuration. Regardless of either NPN or PNP, for collector has to be reverse bias. So, okay, before we reverse bias, that's we are going to connect it over to a light bulb perhaps to tell if it's conduct or not. Then only we reverse bias it. So for this case, it would be one of those objective questions. So first of all, you identify, is it an NPN or PNP? So I've just now mentioned to you, this is point out, so point out, therefore it's NPN and PN type, okay? NPN type. This is the collector side. Okay, so for NPN, in order for this transistor to work, your collector has to be reverse bias. Reverse bias meaning if it were to be N negative, so you connect it with positive terminal, right? So here you're going to connect it over. I'll use another color so that you can see it. Maybe I'll use okay, positive. Okay. Okay. So here, this point to this point relative to here is reverse bias. I hope you can see it, because why is it reverse? Because this is negative and this is positive, so it's reverse bias. This is how to make it work. It has to be the reverse bias. So if it were to be P and P, so you need to have negative this side. So this is one of those objective questions you can see from your reference or text. They will test you out with. They will ask you which would be the right configuration. So if this side reverse bias, then obviously you doesn't need to take care of this side. You just connect over this end, and then over here you need a resistor, the base resistor, and then I'm going to have a LDR here, light dependent resistor, LDR. And then I'm going to use another resistor here and connect to here. Let's go through this. If light comes in, this device is called LDR, light dependent resistor. So what does it does? When you have light impinged on it, this LDR works as intrinsic semiconductor. What happened when you have light or heat source onto it? What happened? The resistance reduce when you have light onto it, meaning electron could flow easily. Okay, so this is what it does. It will going to alter the current. So let me give you a quick one. Now, just in case here, let's for example, if you have 12 volt over here, is connected parallel, 1 point, and then 2 point. So you will expect 12 volt over here, this line, and 12 volt over this line. Says I name this as AB, this is CD. So therefore, the voltage between AB and it will be equals to voltage between CD because they are in parallel, and therefore they will be equals to 12 volt. It's parallel, okay? It's parallel. I'm not going to talk about this part. I'm going to talk about this side first. When in a light, you have light under light condition, you have light on LDR, light dependent resistor. What happened? When you have light onto it, the resistance reduces. Now bear in mind, the amount of current passed through it will still be the same because in series, so the amount of current will be the same. So therefore, the voltage across the LDR will reduce. Okay, because of the constant current based on V equals to IR. If R reduces, therefore current voltage reduces. Why is it so? Voltage is constant. This is series. There's only one way the electron goes into this pipe or this line. So the current will be constant. So here, when the resistance reduces, therefore the voltage across LDR reduces. Now, bear in mind earlier we have 12 volts. Say for example, if initially here would have say 6 volt, let's say it's balanced 6 volt and 6 volt initially. When you have light onto it, 6 volt will go down to maybe 4 volt. Then the voltage here would go up to 8 volt to make it 12 volt, right? So what happened? The voltage across the resistor here, this is VR. Voltage across the resistor would therefore increase because they are over parallel configuration. This is because of parallel. Okay, so VR increases. If EVR increases, voltage across the resistor increases, the current over the base of the transistor increase. Because now, what happened? It's being united here. Okay, so the current would increase. When the base current increase for NPN, therefore the current over the collector IC increase even more. And therefore your light bulb, you will see a light bulb to be light. You have light. Okay, now so this is how the NPN work. For NPN, when you have current over the base, you get a switch on. Okay, the opposite, when you replace it with PNP, when you have current and base, it will have an off. Okay, so I'm going to do it here over the left. So for NPN, when you have your current over the base on, your current over the collector switch on. This is where you have a switch on. Okay, The same is true. How is that so? I will explain it later. Okay. For PNP, if you have current over base increase, your current over the collector will reduce, giving you a switch off. You get a switch off condition. Okay. So they work in opposite manner. Depends on which type of transistor do you use. Now, how is that so? Okay, how is that so? Now, let's consider this. You have, for example, NPN. Okay, either N it's, I think, let's use, this is actually the base, of course. This is the base. So this is called as a collector, and this is the emitter. Okay, emitter just to tell you what type is it actually. Now, in the event when you have base current increase, okay, base current increase, you may regard it as you have more electron flow out here. Okay, you have more electron flow out. You have more electron flowing out. Let me use it. Okay, you have more electron flow out. What happened? Therefore, it will allow electron to pass through it as well. Okay, so therefore, if your current goes in there increase, therefore your collector current increases more. That's why you get a switch on. Okay, now the same is true with NPN. If you have NPN, if your current over the base increase, here they have is sandwiched by PNP, meaning it's positive, you have lost a hole. When the current increase, meaning electron flows out. So sorry that there's no more electron could flow through it. In a block, okay, in a block, okay, if in a block you have P and P, okay. So what happened when the base current increase, meaning electron keep flows out from here. When electron keep flows out from here, what happened? No further electron could pass through it because this side is positive, this side is positive. So therefore, you get a switch off condition when you have base current increase. For NPN, if the base current reduce, then only you get a switch on condition. Okay, I hope it helps you to make it logic, realize what happened, and have a current for NPN, electron flows out, N is negative, right? Negative. Electron flows out, what happened? Sorry, there's no more current could pass through it, therefore, when your base current increase, your collector current goes down and you get a switch off condition. Okay, so this is how it works. Normally it comes up in an essay question. They will normally replace this light bulb to a relay. A relay is you will learn relay in chapter 3, electromagnetism. They will connect a relay to maybe a fan or an aircon, so that you have a temperature change. Therefore, they will switch on the aircon by this electronic diagram. Okay, they make use of this concept. Now, there are a few calculations. Okay, let me still draw this for you so that you will have the idea. Plug and play in, let's go out. Okay, for your practice, going out so it's NPN. Okay, going out. Okay, if it's in, it's NPN. Okay, now something you should know. This is the collector, this is the base, and this is the emitter. Some mathematical value you should know. It's the total current collected by the emitter. Here, it's actually the sum of the base and the collector. IE equals to IB plus C, BC. Okay, IB plus IC is IE. Right. So in some question, they will ask you to look for the current, and this is the equation that you should know. The one with an arrow is the sum of the opposite. First thing, and another thing you should know. Therefore, your IE, the emitter current, is always the largest. IE will be greater than IC. IE greater than IC. And IC should be greater than IB. IB is always the smallest. This is where you input a few milliampere and you actually get a few ampere of current, okay, over collector. If you input a few milliampere, milliamp is so small current, you get a few ampere over the collector. How is that so? Because it's the transistor. 1 mole of an atom, you have huge number and equivalent to Avogadro number of electron. So you have a lot of electron over the collector. So this is the relation you should know. 1, 2 in objective question or in some calculation based related question. Then something you should know also, there is something called direct current gain, DC current gain. Okay, in some harder questions, sometimes they will really use. It's actually a ratio, they call it beta. Beta is actually IC over IB. So beta base, okay? IC over B. So the ratio between IC and IB is called beta. IC over IB is beta. And the ratio is normally 200, around 200. So it's about 100 times. So meaning if you have a few milliampere, your IC will be a few ampere. A few hundreds times, actually a few hundreds times possible. Okay, that's the first thing. Or some other cases, DC current gain also, they would actually tell you the electron diffuse, or they call alpha. Alpha is actually C to E, IC to IE. This ratio is actually it tells how electron diffuse across the junction. Okay, IC to IE, this is the ratio, and normally it's almost 1, close to 1. Okay, just to let you know, something that you are not familiar with, of course. Now, previously I also mentioned the semicon parent material is actually silicon, and it's doped with group either 13 or group 15 to make it either N-type or P-type. Okay, so the parent compound is actually silicon. So for silicon, so therefore, in order for this transistor to work, okay, to function, okay, your voltage over the base, or they call the base current, or the base has to be 0.7 voltage, isn't it? Because what happened, you have this under equilibrium, then you have this depletion layer. You remember in previous video, you need to watch our previous video. So in order for additional electron pass through it, you need to overcome this barrier, 0.7 volt. So therefore, if you want to find out what would be the input current in order for it to work, and therefore you need to know the third, or this is third, the fourth. I think the third is this one. The fourth equation therefore would be the VB, or the V input has to be therefore your IB times your RB, because remember there's going to have a resistor, okay, IB plus your VB, which is 0.7. Okay, it depends on how you how they put it in a question, and this is what you should do. Okay, so this is the current passed through it. It's called IB. It will be the same because in series. Okay, so IB times, this is the resistor R, RB in the base, near the base. You times it, you plus 0.7, then this would be your input current to make this transistor to work. Okay, so these are only theory or simplification of theory. You should actually try 8 to 10 questions of objective question from your workbook to really master this subject, during this section. And why is it NP and PNP work oppositely? Because of how the arrangement. If the electron goes out, therefore electron will pass through. That's why you can switch on. And opposite is true for PNP. So in order for you to proceed to the next question, to the next video, I would personally advise you to perform 8 to 10 questions at least of objective question on the calculation part, on objective session, or for those objective questions that you can get from the workbook. If this is your first time watching my video, kindly subscribe to my channel. I'd appreciate the thumbs up. Stay tuned to my next video.